potential change in a series circuit. Now, let's see this circuit. So this circuit shows that the electromotive force is 12 volt. And there's no internal resistance. If there is no internal resistance, then the potential difference is also 12 volt, right? Also 12 volt. Now, potential difference 12 volt means the difference of the potential is 12 volt. Or it means at this point, the potential, now this is potential, not potential different, potential. The potential here is positive 12 volt, and the potential here is 0 volt. The potential here is 0 volt. Then the potential difference is 12 volt. Now, this is a new concept. Okay, let me explain again. Okay, let me explain again. Now, if the EMF is 12 volt, the potential difference is 12 volt. Then you can assume that this is 12 and this is 0. You can also assume that this is positive 6, this is negative 6, so that the difference between these two potential is 12. Actually, the actual case, it should be positive 6 and negative 6 actually. If the potential difference is 12 volt, then here is positive 6 and here is negative 6. But for the convenience of discussions, I put this 12 and this 0. So why 12 and 0? Because the potential difference is 12. Because the potential difference is 12, so I put 12 and 0 so that the potential difference is 12. Now this is called the potential, not the potential difference. The potential here is 12. The potential here is 0. Potential here 12, potential here 0. And therefore the potential difference is equal to 12 volt. And therefore V1 equal to 12 volt. So try to understand this one first, okay? Or you can assume that here is positive 6. Here is positive 6. Here is negative 6. And the difference is still 12. Is the EMF always 12? Not necessary, okay? Not necessary, yeah? Let me give you another example. Let me erase this, okay? Let me erase this and give you another example. If they tell you that the EMF is equal to 4 volt. If EMF equal to 4 volts, then the potential here can be positive 2 volt. Then the potential here can be negative 2 volt. Then the potential difference between these 2 points is 4 volt. If you don't like this positive 2, negative 2, then you can say, okay, I don't like this. Yeah, so I assume that this is positive 4 volt, this is 0 volt. Also can. The potential difference is still 4 volt. Potential difference is still 4 volt. So let's go back to this one. If the EMF is 12 volt, we can assume that this point, the potential is positive 12 volt. And this point, the potential is 0 volt. So that the potential difference is 12 volt. Okay. Now, the potential is the energy. Is the energies of the circuit. And the potential will remain the same if no work is done. And no work is done if there is no resistance. If we move the charge across from one place to another place, and if there's no resistance, so then no work is done. And if there's no work is done, then the potential will remain unchanged. For example, when the current moves from A to B, the potential will remain as 12 volt, positive 12. Why? Because there's no resistance between A and B. No resistance between A and B. Okay, always remember the potential is the energy, the energy given to the circuit. Okay, so from positive 12 to B is still positive 12 because no work is done and there's no resistance. No resistance, no work is done. Okay, from point B to point C, still the potential is still positive 12 volt. Why? Because there's no resistance. So as long as there's no resistance between 2 points, the potential will not change. Positive 12, positive 12, positive 12. Now, from C to D, there is a 1 ohm resistor. And from E to F, there's a 3 ohm resistor. So altogether, they are 3 ohm, right? 1 ohm plus 2 ohm, 3 ohm. And the potential difference is 12 volt. Always remember, this potential is the energy, energy. So, if we move the currents across these 2 resistors out of this 12 volt, 4 volt will be given to the first resistor and 8 volt given to the second resistor. That is the energy. This potential is the energy, okay? 4 volt, this energy give to the first resistor and 8 volt give to the second resistor. Why? Because this one, the resistance is 2 times higher than this. So more energy is needed to move the charge across this. So when there is a resistance and we move the charge across the resistor, we do work. And if we do work, the potential will drop. The potential will drop if the charge or the current move across a resistor. It will drop. So from positive 12 volt, it dropped to 8 volt. Means that it used 4 volt to do the work. D to E, no resistance, so still 8 volt. From 8 volt, it dropped to 0 volt when it moved the charge across the 2 ohm resistor. It moves the 2 ohm resistor. Chinmei, what drop is the potential, not potential difference. We haven't discussed potential difference yet. We just discussed the potential. So the potential is 12 volt, 12 volt, 12 volt, drop to 8 volt. Remain 8 volt and then drop to 0 volt. And then 0 volt, 0 volt. Here 0 volt, drop to 0 volt. Go here, still 0 volt, still 0 volt, okay? And then the cell, you see the cell supply energy, right? So the cell will increase the potential from 0 volt back to 12 volt when the current move from pass through the cell. So that is how the potential change, not potential difference, the potential change in a series circuit. Now let's see the potential difference. Potential difference is the difference of the potential. For example, here the potential 12 volt, here potential 0 volt. So the potential difference is 12. So if you connect a voltmeter here, the reading will show 12 volt. Then how about if you connect a voltmeter from B to G? From B to G, you will still get 12 volt. V2 is still 12 volt. Why? Because the difference of the potential is 12. Then how about if you connect a resistor from this point to this point? 12 to 0 again. It's still 12 volt. V5 is still 12 volt. So you connect here, this 2 point, or you connect here, this 2 point, or you connect here, you will get the same reading. It's still 12 volt. Okay, AH, BG, or the last one, V5, from here to here. You will still get the same readings. But if you connect the voltmeter C to D, so what's the readings of the voltmeter? If you connect from C to D, what's the readings of the voltmeter? It will be 4 volt. Why? Because the difference is 12 minus 8. The difference is 4 volt. Okay, so 4 volt. If you connect it from E to F, you will get 8 volt. That is potential difference. Potential difference is the difference of the potential. So first you must understand the change of the potential in the circuit first. Then only you can understand the potential difference. And now you know why. Why just now we say that if this is 4 volt and this is 8 volt, then this will be 12 volt, right? We learned that V3 plus V4 equals to this V5, right? This plus this equal to this. And now you know why. So make sure that you understand, okay, the potential change in the circuit, and then try to understand the potential difference in the circuit. Let me give you another example. Let me draw the circuit. Let's say we have a circuit, a simple one. Anyway, let me make it a little bit complicated. Let's put a resistor here. Now this one, both of them has the same resistance. And then let's say this is a 10 volt, the EMF is 10 volt and there's no internal resistance. Now tell me, what's the potential here? What's the potential here? If this is 10 volt, William say it's 10. Okay, you can assume that it's 10, okay? Positive 10, okay? Positive 10, that's no problem, okay? How about this point here? This point here? What's the potential here? Still 10. Okay, good. Positive 10 volt, positive 10 volt. How about here? This point? Still positive 10 volt. How about here? This point? Now the resistance are the same. 1 ohm, 1 ohm. This is 10 volt. So now we move the charge across the resistor. So the potential will drop. The potential will drop. But how much it drop? 1 ohm, 1 ohm. You have 10 volt. This is the energy. This energy will be given to these two resistors. And their potential is the same. So how much given to the first resistor? How much given to the second resistor? Each one 5 volt. Why? Right? Because the resistance is the same. I'll teach you how to calculate that later, not now. You need to know that because the resistance is the same, so the energy used to move the charge is the same. So 5 volt give to this one and 5 volt give to this one. We need to use 5 volt to do the work, okay, to move the charge across this resistor. So therefore the potential will drop from positive 10 to positive 5 volt. Let me erase this. So here, still positive 5 volt, okay. Then how about this point? How about this point? Okay, talk about this point first, okay. The potential difference is 10 volt. So if this is positive 10 volt, then what's the potential at this point? 0. 0, okay. Because the potential difference is 10. So if this is 10, this must be 0. If this is positive 5, this must be negative 5. If this is positive 6, this must be negative 6. Okay, if this is 20, this must be 10 because the difference must be 10 volt. This is 0. Okay, if this is 0, then what's the potential here? There's no resistance between these two points, right? If this is 0 volt, here must also be 0 volt. 0 volt. Then, if I connect a voltmeter from this point to this point, so what's the reading of the voltmeter? I connect from this point to this point. What's the reading of the voltmeter? The reading is 0. No different. The potential difference equal to 0 because there's no difference between the potential. 10 and 10, no different, right? 10, 10, no different. So the potential, the voltmeter will show 0 volt. How about if I connect the voltmeter from this point to this point? So what's the readings of the voltmeter? V equal to what? 10 volt. Very good. 10 volt. How about I connect my voltmeter, this point to this point, here to here? 0. Yes. Very good. How about I connect my voltmeter from this point to this point? 5. 5, because the difference is 10 minus 5. The difference. You take the bigger one minus the smaller one. Okay, now that's how it works. Okay, the last one, okay. Let's say I connect it from this one to this one. The reading will be 5. Let me test you for one more time. I have a circuit. This is 20 volt. I put my voltmeter here. What's the reading? 20 volt, right? 20 volt, huh? How about if I put my voltmeter here? What's the reading? Still 20, right? Still 20. How about if I put my voltmeter here? Still 20. Still 20, yeah? How about if I put my voltmeter... Let me erase this one first. I want to test whether you really understand or not. How about if I put my voltmeter like this? Still 20, okay. That's correct, okay? That's correct, 20. How about I put my voltmeter here? This one. Answer is 0. Why? Because you see, from here to here, this is positive 20 volt, and there's no difference. No potential, the potential does not change. Why? Because there's no resistance between these 2 points. So it's still 20. 20 to 20, the difference is 0.